So we have finished the digital information introduction and we are going into second lesson, which is number systems today. Before we do that, do you guys remember anything about introduction of the digital information?
Yes, I remember what abstraction is.
Abstraction, that was the important topic.
Encoding.
Encoding, that's one other big one that we talked about. So there are three things that we will do today. Talk about the number systems, and then we will go through a video that explains what number systems are. Because there are multiple number systems, not just the one you use. There is one that computer uses. There is another number system, or there are actually multiple ones that they use in software industry. And then we will go through a quiz. Now when you get to this number-based tool and the quiz, I want you guys to watch the second, or take the quiz and watch the second video, and then once you're done and take the second quiz, just turn on your laptops or put the laptops in sleep mode. But I will actually give the instructions when we get there, I guess. I don't want you guys to go ahead and keep clicking on continue, doing everything, because I have an activity based on the second video. I want you guys to do hands-on with the number systems. And before we get to this game, I want you guys to have some idea about what did we talk about when it comes to number systems. So, let's go through the first activity in the number systems. Before we start, there are a couple of questions that I want you guys to think about. The term, what does the term binary means? Before you answer, think about it, talk with your group, right, the person right next to you, and be ready to share. Sophia, if you can put that book away, please. What does the term binary mean? And then the second question is, do you guys know what imperial system means? Measurements in term imperial system?
Is that?
It's the American system.
The American system, basically,
Foot,
foot and inches.
yards.
So, for example, you have two different systems,
Yes.
huh?
But the American system also modified the imperial system, and now they have the U.S. imperial system.
That's an Tim. Maybe you can research a little bit more on what that is. Not right now. And then maybe you can explain next class for us what is the difference between imperial and the U.S. imperial system.
US
I haven't heard, but maybe there is something that they have changed.
Maybe I should. This is like work not.
So when it comes to the second question, so basically, if you, for example, if you take imperial system or foots and inches, 12 inches equal to 1 foot. Now, but the system that you guys are accustomed with or know about is the meters and centimeters, right? So why is not a 12 centimeter equal to 1 meter? Why is it not? Think about that question a little bit, and then discuss with your partner right next to you. I want you guys to, and then let's see.
Because the metric system is
It's a different system.
Because they have different values, so they different values to American numbers.
That's the answer for the first question. What is binary means? Binary.
We
What
think
is
it's
binary?
like the primary numbers, like 0 and 1.
Primary numbers.
Main.
Okay.
Tim, you want to explain?
We have two theories.
No idea. Did you
one of
just
them
Jack?
is- One of
Binary.
Talking.
What do you know about the term binary?
I mean, bi means 2,
Right.
and nary, I'm not sure. Like
Number.
2 numbers.
Two number system. So binary is the number system with just two numbers. Bi means 2, right? You only have two numbers. What? So let's go to the second question, and then I'll come back about the number systems a little bit. I have a couple of questions for you guys if you can answer those. The second question: compare the metric system of measurement and imperial system. Why is it not? Why are they not equal? The way we talk about them.
They're two completely different systems. The imperial system is like, it's set onto different like measurements. Like 12 inches would be 1 foot, and then so many feet would apart or something. But the metric system is on base 10, so you can't really do 12 centimeters equal 1 meter because that doesn't work that way. So
Right, so the answer is like two different systems, right? As you mentioned, like, you know, two things. If both of them are same, if we are measuring the same numbers, it doesn't make any sense, really. Why would we have two different systems? We could just call it one system and then if we are using the same numbers, right? So two different systems. Now when it comes to the number systems, do you guys know any other number systems other than binary? Have you heard any other number systems? Any other names of any other number systems that you guys have used?
I'm not sure, but there's something like Kelvin. They measure like temperature in it. Like
Okay, but-
0 Celsius is like negative 200 something.
Yeah, but those are, kelvins is the units, right?
Yeah,
But
yeah.
I'm talking about the number systems itself, right? Binary numbers they only have two numbers, 0 and 1.
The normal, 1, 2, 3.
The normal 1, 2, 3, 4, what do you call it? What is the name for that?
It's the normal one.
Numbers.
Number system.
Base
Numbers.
10.
Base 10. It has a name, decimal system, right? Deci means 10, right? Deci means 10. And so 10, you have 10 numbers, 0 through 9, we call it decimal system. Have you heard any other ones? Probably not. Okay, so the other one that commonly used is hexadecimal, which is 16 numbers, 0 through 9, and they use alphabets for 11, 10, 11, 12, 13, 14, and 15, which is A through F, A, B, C, D, E, F. Now, you would ask why, right? Why would we want 16 numbers with A, B, C, Ds in it? So the reason is, like, when you want to store a lot of information or you want to make it complicated. So take an example of your password. When you are making password, you want it to make complicated. You use characters, you use all kinds of things in it. So if you go into higher computers, you will understand why they are using 16 numbers. When it comes to security certificates, they want to encode something. Lot of information. If you want to encode a lot of information, you want a bigger number system, right? And that's why they use 16 digits in it. Now, so 16 is called hexadecimal, 10 numbers you call decimal, and then, you know, 2 numbers you call binary. Does that mean can we have multiple number systems, any one we want? If we pick, hey, I want to have 7 numbers, can I have a number system?
Yes.
The answer is yes. You know, we can pick any numbers, we can create our own number systems, but really, does it make sense to have 25 different number systems?
Let me talk.
So while this video is going on, keep an eye on a couple of things. You know, what is the relationship? He talks about the relationship between decimal system and binary system. How they are trying to make you understand what decimal system which you guys use every day, and how does it relate with binary numbers, and what information does it give?
So what is a number system? Well, a number system.
So number base. What is the number base means?
10.
10. For the decimal is 10, right?
It's the amount of numbers,
Numbers.
that it had.
Amount of numbers that he has in that system. What
Yeah.
numbers do we use? That is the base of.
Look at the decimal number system. So the decimal number system has a base of 10. That means that we have a 10.
If you guys can make relate what he's saying with the 2's, 1's, 2's, 4's, right? So you are multiplying by, because in decimal system, every time you add a digit to the left side or, you know, increase the numbers, you multiply by the base 10 every single time, right? 1's, 10's, 100's. And here, 1's, 2's, 4's, like what is that in terms of powers? Every time you're multiplying by 2 instead of 10, right? Because you only have 2 numbers.
First place.
See, if you look at it, right, whenever there is a 0, we learned in the first class, in the previous class, that when it comes to the electrical signals are underneath in the computer, 0s means it's shut off and 1 means the signal. So that means 0 has no value really, and that's why, like, when it comes to trying to convert the numbers, 0 doesn't have any value, we just multiply.
Should use the final result. So let's just look at the ones. This number has 1, 2 to the 7, 1, 2 to the 4, and 1, 2 to the 0. We have 128 plus 16 plus 1. 128 from this 1, 16 from this one, and 1 from that one. When we add these together, we get 145. So we see.
So here's the question, right? I mean, we are coming to the end of the video. Question for you guys. Right? So 145, how many? We have 3 digits. But then it takes about 8 digits to write in the computer.
Yeah.
Why do we even use, first of all, do you guys see, it takes a lot of space to write anything. Really, our decimal numbers in the computer world, it takes a lot of numbers. Why do we even use that? I mean, think about what is the difficulty if we want to represent. Why do we use only two digits? You know that one, but what is the difficulty in representing 10-digit system in a computer?
Ooh,
Right.
I got it. Because let's say you're trying to put 1 and 9, the computer might think it's 19. Because you have to put them next to each other.
Mm-hmm.
And let's say you have like 1, 2, 1, 9, but you want it to be 1, 9, it could mistake it as 19.
But if you design a system, right, that it won't mistake, but it has a value, there won't be. That's what we're talking about, right? That the system is designed already to use 0 and 1, but when you already designed a system, but for some reason they haven't designed it yet. Platon?
Because it's easier for a computer to read only 2 numbers than 10 numbers. And it doesn't matter like how long it is, because it still can read it. But when it gets like short and it has all the different 10 digits, it's hard.
Okay. So the extra.
Me or her?
You go ahead.
So 145 in binary could like represent anything. The ones and zeros in that number could be colored and still represent. So the ones and zeros gives you a flexibility and gives you more chance to add more stuff to your.
So here is the answer, right? Think about it. The computer can make only decision between, there are only 2 things that it can think about, yes or no. So it can only represent information in 2 ways, right? If you want to design a computer using 10 digits, right, it has to make 9 different decisions. What does 0 means? 1, 2, 3. How does it represent 9 different digits? That's why, right, when we were talking about in the previous video, when they were talking about the DNA that has long string, they are still working on the computer because it has to make that many decisions. Every time it sees a different thing, you have to assign a value so that it can exactly say, this exactly means. Today, computers can only speak one language, yes or no in electrical signals. That's why it's very difficult to design anything beyond that, because you have to tell that computer, when I give a 9, what should it say consistently. That's the difficulty part. But once you design that numbers, right? If somebody can figure that out, then your data gets compact. Because today, if we use really in our number system, decimal number system, if you use 8 digits, right? That is like units, tens, hundreds, thousands, 10,000, 100,000, a million. You can represent that not just 145, but you can write it as a million, or even more than a million, 10 million. Right? So, but we can only use that, we have to use this much of space just to write 145. So that is the challenge. On the CodeHS, if you log into CodeHS, before you take your computers out, look at this. Next one is to use the number-based tool. There are 5 different questions. Now, I want you guys to look at the number-based tool. You can click on and off on this and it will tell you what number it is. But there are 5 questions that you can answer. I want you guys to think about these answers. And I want you guys to teach everybody in the class, one group for one question. I'll maybe randomly pick, or if you have an answer, I'll let you guys go ahead and do it. Number tool, look at these numbers, look at these questions and say, okay, what is it? Why does it make sense, or what is this answer? How does it make sense? And you guys explain. Now, you guys can open the laptops. Once you're done with the last quiz, please put the computer to sleep. Only code HS tab. Only code HS tab, please.
Why did you pick oh yeah, you like color.
It's not mine.
What?
Yeah, no.
Any.
Yeah, that's right. You know, usually.
Do we have to answer the question?
Yeah, just, you know, get a piece of paper that you have, just write them down, or just, if you want to talk about it without a paper, that's fine. Go to the number-based systems, yeah, just click on the second one.
Number systems?
Yeah. Wait, should we tell you which one we're gonna use?
You can, yes, I mean, you can pick one and you want to answer one question, that's fine.
I guess so.
But I would want you guys
Wait, I'm
to
confused.
see if you can quickly figure out all 5.
So it's
The number basis.
255.
Mr. Miranda, I don't get the first part.
That's fine, I mean, you don't have to get all of them, we'll talk about
You
it.
don't get the only 6 bits.
How many possible values can be created with 8 bits? That means if you are using all 8 bits, what is that? Yeah, so all of them. How many possible values can be created? Now, if you use all of them, is 255 is your value. But, you know, what does that really mean? Right? So, who can give me the answer for the first one, created with 8 bits?
255?
How many parts?
Okay.
No, 256.
Wait,
So it's 255.
255.
Okay, why you
Oh,
say
you mean if you add
256?
all of them
Plus
to-
128 plus 128.
255.
6.
I did good math. Good math.
Okay, it's a good thing to understand, right? So the answer is 256.
It's all
Right.
added together.
You know why? So the highest possible value when you turn every bit into 1 is 255. That's the value. But we are talking from 0 through 255. So you need to add 0 to it, right?
Oh.
That's also one other number. Like when you turn everything to 0, it's 0 is another number. So that's 256. That's
Wow. Well, cool.
So second question, what is the highest value that can be created only with 6 bits?
250.
Nick,
250. I don't know.
you should have written it down because when you're playing with the number tools, you can turn it on, right? So
254.
3, 4, 5, 6 bits.
But that's not the highest.
64.
That's not the highest.
No, that's only 5 bits. It's 5 bits.
No, but that's also not the highest. You take away the 2 lowest.
It's 64.
No, don't you use.
Highest value, right? We are asking the highest value that
Isn't
can be
that
created
five?
with only 6 bits.
64.
Isn't that 5 bits?
Yeah, but wouldn't you.
No, that's 6.
6
Wouldn't you
bits.
put 128, 64, 32, 16, 8, 4?
Well, so if you do that, let's say,
But then 2 and 1 is.
if you do
Yeah.
that, you are still using the first 2 bits, right? Because the number
Oh, because
system
there's
was wrong.
zeros, yeah.
Yes, you still have zeros,
Okay, true.
which means that's 252 is not. So when you are taking 6 bits, you are going from
It's
left to
64.
right, or right to left. You are using the first 6 bits. 62. So that video should have given you the binary to decimal. There are 2 questions, quiz questions you can finish. Now I want you guys to do this one. Try to do it without using a computer, without using the number-based tool. There is an example that's already provided for you. You can see the sample and try to see if you can understand the example and then, you know, try to solve the problem. And then once you're done with this one, you can see you can do the final activity, which is just a simple game that they have created with the number-based system. Start from here, right? Because see how it's 172.
Yeah.
The highest number is 128. Can you divide 172 by 128? Yes, you can. And what is left over? So you were trying to make all the way to 0, and that's how you do it.
Huh?
not from this one.